Hello everyone, today we're going to look at how to solve problems that sometimes geneticists come across. Now, you're going to need your notes booklet and we're going to be starting at page 9, but I'm going to do a little bit of chatting first of all. So let me introduce you to this little creature now. He looks massive, but in fact you'll see him in context in a moment. This is a fruit fly. Fruit fly's Latin name is Drosophila melanogaster, and this is useful in genetics because these fruit flies have a very short lifespan, and that means they reproduce very quickly. So geneticists can set up genetics crosses and get different types to reproduce, and within days they'll have the offspring, and then within another week or so they'll be ready to reproduce. So they're really useful. So this little chap is actually pretty small. They're called fruit flies because they live off fruit. So this is part of an orange that's been cut in half, and we can see a segment there. So that's like one of the segments, and we can see that these little chaps are pretty tiny. So different types of these fruit flies. The normal ones have got normal sized wings. There, I'm just going over the wings there at the bottom. So they've got normal long wings, but some have got tiny wings. So these are the little small wings. On one of the questions you were doing there the other day, it talked about vestigial wings. So at GCSE we just call them short wings, but the proper term is vestigial. Now, I'm sure you all rushed to the dictionary whenever you came across that word in the questions you did yesterday. Vestigial means that they're useless. And if we look at these wings are tiny. Those flies are not going to be able to fly. Whereas the long-winged fly, yeah, they'll be able to take flight and move from fruit to fruit. So the little chap on the right is at a big disadvantage. Now, believe it or not, there are businesses that are set up to breed these flies because, as I said, they're used in genetics experiments. And if you'd been in school 20 years ago, you would have been breeding flies. So we would have bought them in from fly breeders, and we would have ordered in so many purebred long-winged flies, so many purebred short-winged flies. So we came across the term purebred, and really that means that they are homozygous for that particular allele. Now, let's put it into context here. Well, I'm telling you that long wings flies, if they are bred with other long-winged flies, all the offspring are long. Same with short. If you breed them with other short ones and we get short, we know that they're purebred short and they're purebred long. And if you breed those two, you get long-winged flies. So what does that tell us? It tells us that offspring there has an allele for long, but it also has an allele for short, but yet it's the long one that is expressed, so that tells us that long is the dominant allele. Now, we could pick any L, but it's actually quite confusing. If you're writing capital L and small l, sometimes people get confused, or we could have short and short, but they're pretty messy to use. So we're just going to use the letter A. So we're going to say let capital A represent the long allele, and we're using the capital letter because it's the dominant one. So then we use small letter to represent the short wing allele. Okay, so you can write that in at the top of page 9. Capital A is the long allele for long wings, and small a is for short wings. Now, in the example in our books, it says a breeder has a long-winged fruit fly. Now let's think about the possibilities that we could have in terms of what combinations of alleles. So remember, these are the genotypes. So one that's going to be big A is going to have long wings. This one here is also going to have long wings because big A is dominant, and this one here is going to have short wings. Hopefully you remember that we call these the phenotypes. So the genotypes are the alleles, the genetic information, and the phenotypes are the actual characteristic that they have. Now it tells us in our notes that a breeder has a long-winged fruit fly, but these are both long-winged fruit flies. We don't know whether the fly he has is big A, or big A, small a. We can't tell by looking at it. So you need to write down that it could be big A, or big A, small a. Now, there's no way of knowing what its genotype is just by looking at it. But there is a way that we can sort of work it out. This one here is the only one that we can look at and be sure what its genotype is. If you have a short wing fly, you know that it has to be little a, little a. And we're information to become detectives. I just like Sherlock, so I just wanted to put his photograph up there. But we're going to be detectives, and so we're going to do a little bit of working things out. So we've said the fly could be big A, or big A, little a. And so we're going to cross it with the only fly that we can be definite of its genotype. And the only fly that we know its genotype is the homozygous recessive, which, as we've said, is the short-winged fly, little a, little a. So we've got two possibilities here, big A, or big A, little a. So we're going to work out the two possible crosses. So on the left here, we're going to complete this Punnett square, assuming that his mouse is big A. And on the one over here, we're going to make the other assumption, big A, little a. And we're going to cross both of them with the homozygous recessive, which is little a, little a. Okay, so pause the video, work out what goes in there, and work out the phenotypic ratio, so how many long, how many short. Okay, so pause the video and work that out. Okay, so hopefully you've got that all worked out and in pencil, just in case you made a mistake. So over on the left, that's big A, little a, and so's that. And that is the same, and so's that. So what are those? Well, they have a big A, and big A is for long wings, so every one of those has long wings. If we cross it with big A, little a, that's going to be big A, little a, little a, little a, big A, little a, little a, little a. We have two that are long, and we have two that are short. So what's our ratio of long to short? Well, we say too long to too short, but usually we simplify it down to 1 to 1 ratio. So he's got this fly, he has to breed it then with the homozygous recessive. If he finds out that all of the offspring have long wings, he can be pretty sure that his original fly was this on the left here, big A, which gave all long wings. On the other hand, if he found out that half of the offspring were short and half were long, then that's going to tell us that the genotype was big A, little a. Sometimes you don't always get the right ratios. You know from year 10 that every time a child is born, there's a half of a chance it's going to be a boy and half chance it's going to be a girl. And yet I'm sure you all know families where there are 4 boys or 4 girls or 5 girls and a boy or things like that, where it's not always the ratio you expect. So basically we're saying if it's all long wings, it's going to be big A, big A. Really, if there's any short there at all, it's going to be big A, little a. And that's what it's really in the bottom bit there. So let's, if we haven't filled this in already, if the breeder finds that all the offspring have long wings, he can be sure that it's big A, big A. If he finds any have short wings, that must mean there's a small a present. So he can be sure his original long-winged fruit fly was big A, little a. And the bit at the bottom there is worth highlighting. You always cross with the homozygous recessive, and if you get any homozygous recessive in the offspring, then the parent must have been heterozygous. So to put that into context, in this case, if any of his offspring had been homozygous recessive, then because the parent had long wings, but they've passed on a little a, the parent must have been heterozygous. Okay, now you've got some questions to try.